Friday. How is everybody? All those doing reviews, how did they go? No one can hear a thumbs up. I want to hear, how did they go? Okay, all right. Well, look, the time has now come to kind of relax for a moment, unless, of course, you're presenting, in which case... No, I've heard that these three projects, I should say, are very exciting. So today marks the first time that we're going to be doing a 3-weekly cycle of graduation, and we have 3 fabulous teams to present to you today. Amazing apps I've heard. I know nothing about them, so I'm as intrigued as you guys. For those coming to their first graduation event, the kind of normal housekeeping rules are that we have a team present, and then there is the opportunity to ask questions afterwards of anything you want really about their presentation. You can do this online as well, hence why I'm talking into a microphone without any amplification, is so that the people on the live stream can hear what all of us are saying. But yes, if you guys want to ask a question, there is a box underneath your screen where you can type your question, and the question will be conveyed to the students presenting. So there are no planned fire drills today, so if you do hear a fire alarm, then follow the green signs out the building. Ladies' toilets are that way, gents' toilets are that way, for those people that have not been here before. Right, I'm going to shut up now and move this show on. Please put your hands together for a team called Scripter!
Thank you very much, everyone. Thank you for coming to the presentation. Quick introductions. My name is Nick. We have Andrew, Georgia, and Challen, and we're here today to present our project Scripter. So what is it, you ask? It's a great question. Thank you. So Scripter is a Google Chrome extension which will allow users to retrieve the entire transcript for a video, but more importantly, it will give them timestamps for every instance certain keywords appear. So, for example, my boss wants me to learn about servers in JavaScript, and I've got till this afternoon to do it. I don't know much about JavaScript, and I know nothing about servers. So I think, where do I start? Well, I found a great YouTube video to help me out, but it's 5 hours long. I don't have time to go through that whole thing. So what can I do? I can use Scripter. I use Scripter to retrieve the entire transcript. I can search for the word server, and it will give me every instance in the video in which that word is spoken. I can then click on those links and get taken to all the relevant points in the video, so I can easily learn about servers, and my boss is happy. So let's show a quick demonstration of the app in action. So you just go on any random YouTube video. We just picked one at random, which I found on the front page. It's the Queen's Xmas speech from last year. But we want to find when she speaks about Christmas. So we use Scripter. Now, we retrieve the script. This sends a request to the backend, which will go through cloud storage, Google speech-to-text translate, and use the audio converter, and will provide the user with an actual transcript, as you see when the mouse clicks. There you go, just there. So we now have the entire transcript for that video, everything the Queen has said in the audio. So we can now search for words as well. We've searched for the word believe here, and it highlights where that word actually appears in the transcript as well. So we can find out the context in which the Queen is saying those words. Let's try searching for Christmas, though, because that's what we want to find. Now, we can find this in the script as well, but we've searched for this word, and we've been given the timestamps.
Towards greater understanding. The Christmas story retains its appeal.
Thank you very much, Liz. So, we have now got all the instances where Christmas appears, and we can easily learn about things if we were looking for a tutorial on coding or anything else. If you were to navigate away, however, you think, oh no, I want the script again, but I don't want to send everything away. Well, luckily, the app uses Chrome storage to save the transcript, and you can bring this back anytime you want to use the video again. If you want to look at certain words again or find different words, that is going to help you out. End users for this product, me, you, students, professionals, everyone. This is applicable for anyone who wants to learn something but doesn't have time or wants to find certain parts of videos for quotes, analytics. The possibilities are quite endless. So I'm going to pass you over to Andrew now, who's going to be talking about the back end for the project.
Hi everyone, my name's Andrew. I'm going to talk about in a second, the tech stack that we used, the choices that we made for our tech stack, and why we use them. Any second. Maybe. Okay. It's fine. The main tech choice that we had to make was the speech-to-text service that we used. Early on, we spiked out using JavaScript a number of different speech-to-text services. Each of them had their own pros and cons, really. We really thought that speed and accuracy were the most important things we were looking for over, say, good documentation or ease of use. We decided to build our entire backend in the Go programming language. Primarily, we chose that just to challenge ourselves, really. We wanted to see what it was like to learn a new language and see what it was like to learn a new language as a group. There were numerous languages we could have chose, obviously, but we hoped that the Go programming language would integrate well with the Google speech to text service, because the Go programming language was developed at Google. Speed was obviously really important to us. We found that speech-to-text services take a very long time, or they can take quite a long time. So Go is a compiled language, which is quicker than something like JavaScript, which is interpreted. And we thought the faster we could make it, the better the user experience would be. We used Gorilla Mux, which is a Go library, and it works with Go's inbuilt HTTP handler to provide routing for our backend app. We used command line instructions using FFmpeg to convert the audio files. So we had to convert the audio files from a stereo FLAC file to a mono FLAC file, as we discovered that the speech-to-text service, really that was the only format it could take. We looked at numerous cloud storage options in order to store the audio files in the cloud, but we found that because we were using the free version of the speech-to-text API, we could only use Google's storage buckets. So in the end, that's what we went with. I'll now pass you on to Georgia, who's going to talk to you about the front end and how we work together as a team.
So for our front end, we decided we wanted to go with a extension. This seemed to us like the most natural way for a user to interact without having to flick back and forth between loads of tabs. It also gave us a great way to directly take the URL from the browser, meant the user didn't have to copy and paste it in every time they wanted a new video. But as most people, we open lots of tabs on our browsers, so we had to find a way to get the one that the user actually wanted to send that request to the back end. We did this by finding the active tab, so once you click on the extension, the active tab is the one that you have opened now. So to store the data individually, we use Chrome storage. This was great as we realized each time you open the storage on a separate tab, you could save it individually. So you can open multiple tabs with multiple videos and use the scripter multiple times and it won't affect it on the other tab. The key feature of our extension is that we use timestamps. These are links to the points in the video where you've inserted your keyword and it will go to there. We did this by updating the URL with our current timestamp. We also didn't want to give the user just a list of times, which didn't really mean anything. So we added context sentences so that the user had somewhere that they knew they were going to and that was the correct place for them. For teamwork, the first thing we did when we created our project, we made our user stories. This was really helpful as it helped us break down the user steps into smaller tasks. We then split these tests between back end and front end. In the beginning, we did daily stand-ups. These helped us inform of what each team did yesterday and what the goals were for today. This kind of stopped in the second weeks as the problems became more challenging and required the whole team to be involved. We also made daily goals and kept these on our Trello boards. We divided the tasks based on who wanted to do what and who had the most knowledge. But in the beginning, these mainly consisted of research, as they were all new technologies to us. With these daily goals, our first day, we were quite overambitious. But that early on, that helped us set more realistic goals for the rest of the project. Primarily, we use pair programming, 2 on back end, 2 on front end. But for more difficult challenges, we all worked as a 4 and did mob programming. This was really beneficial. We'd come together, discuss the problem, go away and find our information and come back and make the solution. Go, our language for the back end, was really helpful with this swap, because we all wanted a full stack experience, so we wanted to swap who was on back end and who was on front end. So the Go language was really useful as it was so strict, so people could only write something a certain way. So no matter what, that was it. That was the only way you could write it. I feel like how our team worked so well was through communication and writing really clear code, and that's how we managed to get the project out. I'm going to pass you to Challen, who's going to discuss the problems that we had making this.
Hi guys, so one of the obvious challenges that we came across was learning Go. Previously we'd only used JavaScript, and there were some major differences between the two. So one of them in particular is we got used to saving very regularly in JavaScript just to preserve any line of code that you were happy with. We quickly had to get out of that habit when we were using Go, because if you save the file and Go's not happy with some of the code that's in there, it will cause some issues. One notable example is when we tried to import certain modules and save a file without implementing that module, Go will just assume that you didn't need the module and delete the import without even notifying you about it, which is obviously quite frustrating if you're trying to use that module and you don't understand why it's not working. So we overcame learning Go just purely through reading the Go documentation and through watching online tutorials. The next challenge that we came across was extracting the audio from the YouTube video. We actually focused on YouTube just because it is the most popular streaming service on the web. However, they are not keen on people accessing the data behind the videos. Despite the fact that our application is completely qualifies for fair use, as we're just directing the user back to YouTube's page, it was still very tricky for us to access that. So we did spend a day quite early on into the project looking into how we could extract the audio using code that we'd written, but we learned that it was just going to take far too long, and we just couldn't allocate enough time during the project to do so, so we ended up using a third-party module to do that. Some issues using the Google Speech-to-Text API. When we were doing initial testing, we were using very short videos of maybe 5 to 10 seconds. This involved very low, short processing times from the API. However, when we went into further testing and started using videos that were several minutes long, the processing times quickly ramped up. Also, the accuracy of detecting what someone is saying is quite varied. So if someone is speaking very eloquently, such as the Queen, for example, which is why we use that video, it can very easily pick up everything that she is saying. However, if someone has a more obscure accent, such as Andrew's, it very much struggled to pick that up. One thing we did look into is using a locally installed speech-to-text software, as we thought that would be a lot quicker to process, and it may be a little bit more accurate. However, when we saw the price tag of £300, we quickly discarded that idea. If we were to come back to it or continue, some improvements we would make, one feature we really wanted to implement but didn't have time was being able to search by multiple keywords or terms, and we think that would greatly improve the user experience. We would also obviously look to create our own code to extract the audio from the video. And we would also look to adapt for other websites other than YouTube and for other browsers other than Google Chrome as well. As for the future of Scripter, I believe that as speech-to-text software becomes a lot more advanced and has shorter processing times and is a lot more accurate, a tool like Scripter could become commonplace for helping a user of the web easily and quickly search for information that they want to find. Anyway, that's it from us. Thanks for watching, guys. If you have any questions, please feel free to ask. Cheers.
Amazing. Can I add it to my browser now?
Not quite.
Honestly, that is so useful. I'm sure that all of you are often watching videos going, hang on a minute, don't quite understand that particular bit of code. How do I find a video to help me out with it? Yeah.
Yeah, there was many times whilst doing the project that we could have used it.
Amazing. Certainly with my poor DIY skills, my wife probably wishes I had this now rather than it's sometime in the future. And as to the number of tabs, me and Ruth often have a battle internally to see who has the most tabs open at any one given moment in time. I know it's poor behaviour. But anyway, enough about that. Who's got some questions? Come on, don't all stick your hand up at once. No. Right, two together. Sorry, I don't know your name, but I will pass it back to you, the microphone that is.
That was amazing, by the way. When you were starting off with the user stories, how did you come up with those user stories, and how did you shape them and size them?
So essentially, our user stories were basically what we wanted. This kind of app was built for us to help build this app, essentially. So we kind of did it by what steps we wanted and what the key features we feel would have been beneficial to us, essentially. And we developed them by what were the baseline things that we wanted, and then kind of like nicer things, and like things like we could have just had a link, like a simple, this word is mentioned at 2 seconds, but without the link. So we added those based on what we felt was most important and also what would give the user the best experience.
Right, I did see another hand go up down here. Veronica, is it?
I know you had a few problems with Go. If you had the chance again, would you still stick with the idea of learning a new language, or do you feel that it took up a lot of your time to solve those problems and learn Go?
So I feel like because the notion of learning a new language was so that we could experience it as a team and really challenge ourselves even further than making a very difficult to make app, I think we'd still look at using a different language. However, we might not choose Go. I mean, the reason we did was because we felt it would be very compatible with all the other technologies we were using. Google speech-to-text, Google Cloud Storage, etc. And because of that, it was our go-to one. No pun intended. Yeah. So I think it would be very hard for us to actually choose another language to use. We could have done it in perhaps JavaScript, I'd say, yeah, because we've learnt that through the course. But Go seemed a lot more compatible and suitable for our needs.
Thanks, Veronica. Any more questions? Hi.
Hi, a great project, by the way. Because Go's kind of a relatively new language, how did you find the documentation? Was there quite a lot on Stack Overflow? Was there a lot of support there?
Yeah, actually, one useful thing was that some of the services that we were using, such as Google Cloud and Google's speech-to-text API, they did sort of help you along. They had some examples of usage in Go language, because obviously it was a language developed by them, so they wanted to promote that. So yeah, that was very helpful to us in figuring out how to use it with those services.
Brilliant. Excellent. Right. Last chance for questions before we bring this one to a close. Okay, brilliant. Look, honestly, astonishingly great project. First time a team has ever used Go, and I think, again, it just shows how much can be achieved, no pressure, during project phase. Well done. Scripter. Welcome back, everyone. And again, without any further ado, I give you Reserved.
Thank you very much. Good afternoon, everyone. We're really excited to be here. A bit nervous as well, but I guess that's everyone who's here. So let me start the presentation with asking a question. Actually, not even a question. It's more like a situation. So imagine that you're booking a restaurant. What is the most important thing that you think about when you're booking a restaurant? Is it the occasion that's more important, or is it food? Well, to be honest, whatever the reason for booking a restaurant is, our team believes that in addition to just booking a random table in a random restaurant, you should also be able to book a certain table, and you should be able to choose the table exactly where you would like to sit at. So imagine the situation that you're trying to book a restaurant and a table for an important first date, and you end up with a random table in the middle of a crowded room. And that's not really a good situation, is it? And to be honest, we've done some research, and that's what the market seems to think as well, because there's more and more restaurants now that put 360 images and views of their restaurant on their website. So you can go into the restaurant, look around, get the feeling, get the atmosphere. And because the photos and the videos just don't do the same thing, actually. So that's where our application comes into play, because what we created is an application that doesn't just let you know all the details you might want to know about the restaurant. It also lets you go into the restaurant, look around in 360 view, and pick the table you want to book. And who exactly are we? We had Matt and Tom working on the back end, Tim and myself on the front end. And that's kind of enough about me talking and trying to sell you the idea. Let's see the application itself. I'm going to pass it over to Tim now, so he can walk you through our demo.
Thank you, Susie. Okay, so let's get the video loading first. Okay, so we present with the login screen. Okay, Felix is going to add his email address and shortly his password as well, obviously. Okay, so where would you like to go today, Felix? He's going to search for an area he'd like to dine in. So he's gone with London. So we get a list of nearby restaurants in London. He's changed his mind and he's going to go with Manchester. Good choice. So now we've got a list of nearby restaurants in Manchester. And we've also got the option for the top rated restaurants. So now we can go to map view and can get an idea of the locations where they are. And we're choosing a restaurant from map view. And now we are going to look at reserving a restaurant. So we're taken into this 360 environment of the restaurant. You can see the table pointers above all the tables. And we will be able to click on one of these to make a booking. So we clicked on the table, we're now taken to a scheduler. We can choose the date and the time of the table. We make the booking, and now we have the table number and the booking details. So to further go on, we can go back to the restaurant that we made the booking at. And we will go back into the 360 environment, and now we can see that the restaurant, the avatar of the person who booked the table in the restaurant, to give us further visual confirmation. So I'm going to pass you on to Thomas, who's going to talk about back-end.
Yeah. Thanks, Tim. So as we decided as a team to create our backend and in Note and Express, as you can see, we decided that this would be the best option for mobile app, thanks to its non-blocking and asynchronous code, where synchronization happens fast, which is really important on event-based application. We also use Firebase for storaging purposes, like requesting or sending the pictures, which we find out that it's widely used in mobile development. We also deployed everything to Heroku, and thanks to its low configuration, we had more time to focus on the main points of our application. So how it works, the app sends the request to our database, and then database verifies the data and rather sends a response from itself or from the Firebase. Now I would like to pass you to Susie, which I introduce you to the front end.
Thank you, Tom. So the front end of the mobile application that you've just seen is written in React Native. And this seemed like the best choice for us because we wanted to create an application that works on both iOS and Android. And we only had 2 weeks to do this. So to save time, cross-platform development was the way to go for us. So we started the development by spiking out. We wanted to see if we can get the core functionality done quick enough to build a whole application around it. So this includes, for example, access to camera, taking photos, uploading those photos to Firebase. And yeah, so once we've got that done, we moved on to creating design mockups in Sketch, which you can see on the right side of the screen, some of them at least. So once that was done, we actually moved on to the development itself. So we used Expo for React Native because we are all new to React Native. So we could really use the help that Expo gave us. For example, it was really useful to be able to test our application on a real device, which is what what you've just seen with the screen recording, because that was our application working live. So. And then we run into some challenges along the way, of course. So the first thing I think, the biggest challenge when we started developing it is how to actually get the beautiful mockups to look the same in React Native. It was quite a challenge, but then using components and native base and different packages, we managed to make it look almost identical. Another thing that was quite difficult was the navigation. We had to learn how to go from one screen to another, how to send the necessary information, how to send props. And yeah, and then another thing that was quite surprising that we found hard was how to do debugging and like console logs. And for that case, we decided to use Reactotron, which is basically just a really good tool for speedy development and debugging. So that's it for my side of the front end. Now I'm going to pass you to Tim, who will walk you through the VR view and how it works in the application.
Thanks, Suze. Okay, so the tech used for the virtual environment was React 360 with VR components. The reasons that we use this is mainly because it was built by the React Facebook team, so it had that credibility. Also, it had a lot of familiar components because we used React in the past. And we wanted this familiarity because it was a VR application and a new concept to us, so we kind of needed those little helpers. So, as I say, it's part of the React family, and it also gave us that confidence in it being a viable solution. So it was a new tech which presented us with not just a solution, but also a challenge. As mentioned before, there were similarities. There was lifecycle methods, component libraries, and these formed an integral part of 360, which was helpful. Spiking out ideas. So the docs were clear, but they missed important details. So we had to do a lot further digging. The React 360 GitHub community only had about 6 semi-active members. So despite this setback, we carried on because 360 was a quick mover in setting up the scene, and we were confident we could build on this initial functionality. So the next steps were placing elements in the scene for the tables and the pointers, and this was done on a coordinate system. The coordinate system was actually quite buggy. And the 3D elements would go transparent for no apparent reason, but we persevered and got it working. The next step was buttons. We managed to get event triggers working for tables and pointers, and this was similar to React, so it was very helpful. The final stage of spiking, we got everything working in a static development environment, and there was no interaction with the database or remote file storage at that point. But once this was done with the static environment, we were ready to roll it out as a concept for integration with backend and native. So I'm going to pass you on to Thomas now, who's going to talk about workflow.
So for our workflow, we use Jira, which drastically reduces the time of planning. We also had morning and evening stand-ups where we could express our ideas or go through the challenges which we met that day. And for the bigger challenges, we were using like a pair programming, which helped us to solve the problems. And for the really big challenges, we use like a mob programming where everyone just focus on this one problem. And now I would like to pass you to Matthew, which got a big surprise for you.
Thanks, Tom. So the backend, as Tom has explained, is just a simple RESTful API that connects to a Postgres database. But alongside me and Tom developing it in Node, I've replicated it in .NET Core. The speed of the API is essential to the responsiveness of the app because a lot of the interactions rely on patch requests and get requests. So the hosted version that I've got up on Azure is 4 times faster than the one we've got on Heroku. Now, I predominantly think that's because it's on Azure rather than a free Heroku account, but for that reason we would implement it if we had more time on this project. How did I approach this challenge? Well, I approached it with a Node mindset because that's what's been taught on this course, and I had no prior experience of C#. So I'm going to talk about a few differences between the languages. The first off is the IDE Visual Studio. It has a lot of boilerplate templates that lay out the structure for you. The structure is very similar to how you would do it in Node. Notable exception would be models are often known as repos in Visual Studio, and that those directly interact with the database. That leads on to another difference that I found. So JavaScript versus C#. JavaScript doesn't have interfaces. So an interface in C# is like a contract of what the class should be or contain. And in this case, I found Visual Studio was very clever because it allowed me to not explicitly declare a new instance of a repo in every controller. I could just say I want that method off that repo and it would know what I wanted. And I think there's a lot of other uses to those interfaces. You can do a lot of conditional stuff at the start. So I found C#, I quite enjoyed it. I quite like the strongly typed nature of it. It's forced me to be quite sort of on point with my naming conventions. I like that about it, not sort of magic numbers or anything like that. Going forwards, we would implement this back end, but we would also have to consider existing restaurants' booking systems because we would want to integrate our back end into theirs, hopefully. And on that point, I'll pass you over to Susie, who will finish off the presentation.
Thank you, Matt. So we've just seen the B2C side of our application, but going forward, it would be really nice to have a B2C side as well, probably a website where the restaurants can register their interest, upload their data, and take the photos, upload the photos so we can implement it into our database, and then we can display it in the application. So thank you very much for the attention, and I hope you like the application at least half as much as we enjoyed working on it, because then we're good. So thank you very much once more for the attention. Does anyone have any questions?
Not only have you created one of the most beautiful apps we've seen for a little while, you've also done it in C#. Unbelievable. Great work, Matt. Well done, team. It's the first time, so another week of first, the first time we've had a C# built app, is that right? No, we have had one more. But one, yeah, okay, we've had C# before. That's just me. That's just me and my bad memory. Right. Questions? Come on. Hey. Alex.
Can I ask where you got the 3D environments from?
So the 3D environments were from React 360 stitches together an equi-rectangular photo. But to make the equi-rectangular photo, that has to be done in a mobile app. Had we more time, and it'd probably be a few months in terms of time, we would like to make that app, but it involves quite a lot of maths, I think, to actually be able to turn that image into something that maps onto a sphere.
So could it work with like Google Virtual Tours or
Yeah.
Matterpoint or something like that?
Yeah. Yeah, we to get some of the views, we used Google Street View, but we actually went into restaurants and took them ourselves, and it takes like 50 photos in a sphere and stitches them together, and then you end up with a weird equi-rectangular photo, and then from React 60 we stitch it together from that side.
Very cool. I like it a lot.
Cool. More questions, please. Room? Come on. There's got to be at least one more question. So, Matt, had you done any C# before?
No, I had previous work. I was in microphone. I was an e-commerce data coordinator, so I messed around with a lot of spreadsheets. So I have touched VBA before, so I'm not like complete stranger to strongly typed languages. But no, I've never touched C# before. 2 weeks ago.
And Azure?
Azure, no, but that was quite easy deployment on that.
Easy. Yeah. Right, okay, well, if there's no more questions, let's give it up one more time for Reserved! And give us a couple of minutes and we'll be back with more than just one transformation.
Ladies and gents, so Amal's taken leave. Unfortunately, he's got a Liverpool match to go to. So I'm just going to quickly hand you over to Oculo.
So, good evening, distinguished panel of judges. I'm Joe. This is John. This is Carolina. This is Ewan. And this is our app, Oculo. So, Oculo is a cross-platform accessibility app for colour-deficient users. We're going to run you through a quick demo of how the app works. So, on load, the user is met with a simple little guide of how each of the buttons works and how each button operates. And then we go to the camera. So here we see the camera in use, and from here you will see from the bottom the options will slide up, and the user can then input their color deficiency type. In this case, we are selecting Proton, and the two options above are monochromatic and high contrast. Monochromatic will shift everything but the problematic color to black and white, and high contrast will change the problematic colors to a more contrasted version. So basically, for the design and of the whole app, we really wanted to keep it really clean, really minimal, really sleek. So we just went with complete black and white, so that there would be no miscommunication of what everything was doing. We went with simple icons that were easy to understand, and the main design aspect was to keep it as clean as possible, so that there'd be no confusion on the user end. The app's initial prototype was created using JavaScript and the HTML element Canvas. So we've got a little example here. On this side, you see the original, and on this side is the canvas in action. So what's happening here is the webcam footage is being pulled onto the canvas, and then each pixel, its data is being then taken away, and the RGB values are being manipulated by an algorithm that was built from scratch that would detect the color, translate the color, and then perform a shift that would mean that problematic colors were then changed to something that would be more understandable. To talk more about going from browser to mobile, here's Ewan.
Thank you, Joe. Hello, everyone. Our initial plan was to use React Native and the Expo toolkit, with the phone performing all of the image processing and displaying it with Canvas. We had a look at Flutter, but we weren't really feeling brave enough to try image processing with a new language such as Dart, even with all the available tutorials and the help of Shaq's cake metaphors. We soon found out that we couldn't use Canvas or WebView with Expo, so we had to go with vanilla React Native. This meant setting up Android Studio to use the emulators and adding various lines of Java to get the packages working. So much for avoiding an unknown language. Just to get the RBA data from the image, we tested lots of NPM packages with React Native. These included React Native Image Crop Picker, React Native Get Pixels, React Native Image Pixels, React Native Image Crop Picker, React Native Pixel Color, React Native Color Matrix Image Filters, and the list actually went on, but yeah, we had several problems, as you can tell. We then eventually decided to pass all the processing to Google Firebase, where we could use Firebase functions in a Node.js environment, and store the pictures in Firebase storage and use the real-time database. This came with its own issues, including timeouts and unknown bugs, such as dirty rectangles and tainted canvases, sorry. I'll hand you over to John to explain what we eventually did.
Thank you. Hello. So as you can hear, doing this just became more and more convoluted and complicated as time went on. So I'm going to try and explain what's actually happening when the app takes a picture. So the user takes an image. That JPEG is uploaded to the Firebase storage. Using the Firebase cloud functions, we resize the image, make it a little bit smaller. The image is then converted into a really, really big array inside of a JSON file. It looks like this. And there's about 500,000 elements in that array. Like when you're doing cars, it's cool doing like loops and stuff, but looping over like 500,000 things is ace. JSON file, this JSON file, newly created JSON files, overwrites the initial image, and a download URL is input into a Firebase database. Meanwhile, back in the app is listening to these changes in the Firebase database. It hears a change, a new download URL has been generated. It downloads the file, extracts the really big array, and saves it locally. Once we have this array on the device, we run it through some like image processing stuff which we made ourselves, and once this is like gone up to the cloud, come back, we reach the next step. So this is like basically this line here is going to like draw the new image onto like a canvas inside of a preview of the app. Does all this, colors transformed. This has a bug in it which doesn't work, and so we can't do a live demo. Apologies. So that's kind of how it works. I'm going to pass you on to Carolina, who's going to talk more.
Thank you, John. So, I think the future ahead of us is really bright. Over the past 2 weeks, we've managed to achieve so much. We've made a successful Firebase integration. We've got a working React Native app, which we made for the first time. Well, almost working, except for the exception that John was introducing to you. And we managed to persevere as a team, even though we had problems. Nobody gave up. So, I think that we've done really well. And if by any chance we were given more time, we would proceed and do more. Like, if we got a week, we would make it more user-orientated. They could have profiles, they could have opacity, they could have sliders to adapt every filter to their own needs. We could do that, I believe. If by any chance we got a month, we would definitely try to implement the live view, which was our core idea, though unfortunately we didn't manage to get it on time. Then, if by any chance we were given a year, and we're lucky enough, we would use object recognition and other things which could help to introduce the world of color for people who can't actually see color, or even go to the world of people who are blind and explain what's in the image using voice and some generated data. That would be cool, wouldn't it? And if we are even more lucky, in 10 years' time, I believe we could just clearly inject that into people's brains. Thank you.
If anybody has any questions, please. If anybody has any questions, please. Yeah.
Thank you very much. Ladies and gents, I think it's pretty obvious to say, technology can do some amazing things, but what's interesting is that, with Northcoders, we prove that it doesn't have to come from a very stereotypical background or an archaic background to achieve that. We've had some amazing ideas. Something like this actually can help individuals all over the world. So, could we just give them a round of applause, I think, for some good ideas that have actually come out that, don't currently exist in the market? Now, I know they've had a lot of challenges, but I think, it's a prime example of what can happen out there in the real world. You don't always hit your deadlines, but it's also about learning from your stumbling blocks and how you then reapproach it next time. But I think it's time you guys have a little bit more pressure on you. So have we got any questions in the room?
What would happen if you would have 20 years' time?
Oh, you have an idea?
Retirement.
Yeah, more or less like that. No, well, it's right. I have to answer it. Oh, right. Okay, I'll try. So 20 years, let's say. Well, first of all, we will not have the barrier of mobile phones. That was in 10 years. I think you can become the object yourself. Yeah, that will be.
So just to expand and give a slightly boring answer, we are using quite a lot of technologies that are already set up. We can upload images to Firebase. We have a database set up there. Given another week or something like that, we could have user accounts that have cloud storage for each user. We have a database of what their color profile is, what colors they can and can't see, and we can edit stuff on the fly with that. The scope for this is like, actually there's some work to be done. Do you know what I mean? If that image thing worked, like everyone would be able to do it now, it'd be wicked. You know what I mean?
Hi, hello team.
Hello.
I feel your pain. I'm just curious. You said you were doing this, making this massive array on Firebase. I mean, was that something that was possible to actually do on the device? And the other thing I'm curious about is you're doing static images. I mean, do you think you would have got to? I think I'm correct in saying that. Do you think you'd have got to video in due course?
I think
so it's kind of two questions.
Yeah, well, the second part, I think video, real-time, static, and video were all three that we really wanted to hit, but after getting many blocks in the way, we really had to home in on what we really specifically wanted to do. The main issue was that in video, the array would constantly be changing as the pixels constantly changed, so that was something that probably with more time we could learn more about, and I forgot the first question. What was it?
The first question was, are you, I think, using the back end to make this massive array? But I'm kind of curious as to, could you have done that within the app itself, within the front end? Maybe, I don't know.
I'll tell you that. The packages we got from NPM, we couldn't get to work on the mobile, so we had to send it somewhere else to use Node.js more generally.
So you're basically using a cloud service to do it?
Yeah, and it could supposedly process more at the same time.
So yeah, I think like pushing a lot of the functionality up to cloud-based meant that we could get out of like a React Native environment and start using Node stuff. And obviously there's like tons of cool stuff that you can do with Node. So like extracting the image, putting it up there means like, look at all these cool packages you can use or whatever. So that kind of opened up a few new things, and we did literally spend like a week trying to do it locally, and it's just a nightmare. So yeah.
Thanks, guys. Any questions? Yeah. Oh.
Hi guys, I think the concept and the ethic is really good. It's really incredible, really. I've got a few colorblind friends who would really like that kind of thing. What kind of integration do you think there would be for using it with other apps? For example, there are other apps like Facebook or Instagram that would give you functionality to use the camera. Do you feel like you would like to explore integrating the app into taking pictures with other applications as well? Do you think that would be something you'd like to explore?
I think when it comes down to accessibility, I think integration should be heavily considered, because you would want anything that anybody uses to be accessible for everyone. I think especially within like Google Camera for Android, and even the camera app on iPhone would be a great way of, hopefully in a really broad way, that yeah, I do think that would be a really great way to implement this kind of idea and these kind of functions.
Any more questions from the room? They got away with a live demo. If you want to challenge them, please.
Have you considered the impact of different white balances with regards to different types of light on how the colours might change? Would you rely on the automatic settings of the camera, or would you allow the user to change settings themselves?
So the camera that we used was React Native camera, and it does have quite a lot of options in terms of white balance. However, they are kind of the standard like clouded, heavy sun, indoor. The auto worked pretty well because the thresholds were set up to incorporate quite a large, or quite a broad spectrum of specific colors. And once that color was no longer recognizable, it was classified as white. So say heavily pastel colors would be considered white, and heavily dark brown colors would be considered black. But the thresholds were something that we really had difficulty with inclusivity and exclusivity. So as long as you are within reasonable difference, like distance, obviously it's not going to work if you're over there and the subject is over here, but white balance didn't throw too many issues.
Thank you. Any more? Or are we all too hot? For those of you watching on YouTube at the comfort of home, it is extremely warm in the room. Well, look, thank you very much. Ladies and gentlemen, thanks again for coming down for another presentation. Please give a round of applause for Oculo. Thanks again to everyone for coming down. For those that have watched on YouTube, again, thank you. James from Natta, we've missed your questions. We are now moving to the next showcase will be in 3 weeks' time. So we're now moving away from the 2 weeks. It'll be in 3 weeks' time. So thank you again for coming up. And we'll hope to see you again soon. Cheers. Take care.
Oh,